Hey guys, let's continue talking about our incremental processing pattern. So let's say that we managed to find the data that has changed in our source layer. And now we want to decide what to do with it. Do we want to insert new rows or update existing ones? And that's the place where merge statement will be very useful. And that's the topic for today. So let's get started. All right, so let's talk about merging data from our source layer to the target layer. And we'll use merge statement for that purpose. And now, merge statement, its syntax, it might differ between different query engines, but more or less the logic is similar between all of them. And let me start with showing you how merge works, what's the purpose of it. And let's jump into whiteboard and let me start drawing it. Later on, I will show you real life example in Databricks, but let's start with some theory. So, whenever we want to merge some data, we have to have two data sets. So the first one, let me draw it here. That's our target data set. That's the table to which we want to load new data. So let me call it existing data, or we can call it target table. And for simplicity, let's assume it has only two columns, like ID, that's the primary key, and some value column. And let's say we've got row with ID equal to 1 and value A. We've got row number 2 with value B. And we've got row number 3 with value C. A very simple scenario. That's the first data set. Apart from that, we have to have this new data set. The data that we detected is the new that we have to process and insert or update in the target table. So let me draw it. And let's call it our changed data. Change data, or our source. And let's say for simplicity again that the structure of those two tables is exactly the same. It might not be the case in real life, but just to explain how merge works, that is fine. So we've got ID and the value columns. And let's say that in this changed data in our source data set, we've got only two rows. We've got a row with ID equal to 1 and the value D, and a row with value of ID 4 and the value set to E. And we want to grab this data and merge it into our target table. So what merge requires is, first of all, those two data sets. And we have to tell our query engine what is the source and what is the target. Then we've got to indicate, all right, but how are we going to join those two tables? How are we going to match the same row from source with the row from target? And we do this by providing some column or columns based on which this join would happen. In our case, it is simple. We've got this primary key, this identifier column, ID, right? So we know that the match will happen based on this column. And then we have to decide, all right, so if we have a match between source and table and target, what do we want to do with it? And in our case, let's say we want to update our target table. If there is a new row in the source table with the ID that already exists in our target table, we want to update the target table with values from the source, right? And in our case, that's exactly the case for ID number 1 because, well, it exists in both data sets. And this row we want to update, which means that we would take those values D and use it instead of value A. We want to update the target table. right? But what if there is no match between source and table, source and target? And that's the case for this row, because we don't have here in our target table any rows with ID equal to 4. And in this case, we would say, all right, if there is no match, then just insert it as a new row, which would result in adding new row in our target table with ID set to 4 and the value set to E. And that's it. And this can be done, and this logic can be written using a single merge statement. So let me show you this in action. So let's jump to Azure Databricks, where I will show you how merge works. And I will show you two scenarios. First of all, I will start with a very simple, very basic data in which we could observe how the data changes, and then we'll move on with some performance optimizations as to what should we do to make it faster. Alright, so let me start with creating some structure in my Azure Databricks Unity catalog. And what I will do is that I create new schemas, bronze and silver, and then within each of those schemas, I create a table. Customer source, that's our source table, and customers target, that's our target table. In both cases, their structure is exactly the same. Why? Because in this situation, I just want to show you how merge works without focusing on some business logic that probably you would implement when moving data from one layer to another. So the tables have been created, and let's insert some sample data to our source table, those 4 rows. And let's see if this data exists in our source table. It should, because we just inserted it, right? And we should see those 4 rows. And yeah, we have them, right? We have customer ID, name, city, and information when this row was last updated in this particular table. Now, this data is completely dummy. It doesn't represent any actual data. It's just used for learning purposes. And in our case, this customer ID column, this one, we treat it as an identifier of the column. Let's also verify that our customer target table to which we load our data is empty. It is. It's empty, right? And let's move on with writing merge statement. And as I mentioned at the beginning, when using merge, we have to provide some information. So first of all, we've got to use this merge keyword, right? We have to tell Databricks to which table we want to merge our data. And in this case, we want to merge into our customer's target table. Then we have to indicate, all right, but what data we would like to use as a source. In this case, we just grab all data from our customer's source table. The logic might be more complex, but at this moment, this is fine. Then we have to indicate, all right, but how are we going to match those two data sets, source and target? And in our case, it's super simple. We do this based on customer ID column. That's our primary key. And then we decide, all right, so what to do if there is a match between a source and target by using this when matched then. And in this case, if there is a match, we simply update our target table with values from the source, right? We set name and city in the target table to values read from the source, and we set last updated date to current date, just to indicate when this update actually happened. If there is no match between those tables, meaning that we have a new row in source table that doesn't exist in target table yet, we want to insert it to target. And that's it, super simple. And let me run this. And now, because our target table was empty, we just created it, right? What happened is that, well, 4 rows were inserted to the target table and nothing was updated because the target table was empty. And let's verify our customer's target table that indeed it contains those 4 rows. So for sure, insert operation is fine, it works. Let's complicate our scenario a bit and let's simulate 2 additional loads to our source table. So this is the load that happened, let's say, on the 1st of February, and the other one that happened on the 2nd of February, right? And let's see how the data in our source table looks like at this moment. And we've got 3 parts of data, each of which was loaded at a different time. So those 4 rows are our original data that we already inserted to the target table. Those 3 rows are loaded on 1st of February, and those 3 rows were loaded on the those 4 rows were loaded on the 1st of February, and those last 2 were loaded on the 2nd of February, right? So here we simulate that data to the source table is loaded on a daily basis, and it is appended, it's accumulated over time. And now, please note what will happen if we try to run this merge statement one more time on a different source data. And I didn't modify this merge statement in any way. It's exactly the same as it was previously. But this time it failed. The merge failed. And the error says that multiple source rows matching target row. And it simply says I cannot perform merge operation because I don't know which row I should choose. And what does it mean actually? So let's get back to our source data and let's take a look at, for example, values with customer ID set to 1. And you can see that we've got 3 versions of this Alice row. This one, and this one. And simply Databricks doesn't know, alright, which version, which row should be used to update our target row, right? It is not able to decide it on its own. So we have to help Databricks to indicate which rows should be chosen in case we've got duplicates. And that's a very common case. You will have duplicates, a lot of them, unless your source layer is already duplicated. In my case, it is not. So what I added to my merge statement is this. And it is a simple qualify statement that partitions my source data by customer ID and then chooses the row with the latest value of last updated column, right? So I simply deduplicate the data. So how it looks if we take a look at the data. So again, let's analyze it on Alice. So we've got 3 rows with customer ID set to 1, right? We partitioned our source data based on customer ID. And then our query looks at last updated column and uses the row with the latest value. So in this case, it would be this row would be taken into consideration for merge, and those 2 would be ignored. And the same logic applies for every other customer ID. And hopefully this time it will work. So let's run this merge statement that duplicates data on the fly. And it didn't throw an error, it went fine. And we can see that 4 rows were updated, 1 row was inserted. So let's verify it. Let's see how the data looks like in our target table. And yes, we've got 5 rows. This Eva from Cambridge is a new row. and those 4 rows were updated, right? Those existing 4 rows. Alright, but what if we would like to check exactly how the data changed between those merge operations? And the nice thing is that our customer's target, actually every table we use here, is saved using Delta Lake format. And I have a video on this format if you want to read or learn more about it. And one of the cool features of this format is that it tracks the history automatically, right? So we can see, we can check how our customer's target table looked like in the past. And we do this by using this describe history statement, right? And we'll see in a second that this target table had 3 versions, right? The first one was the result of just creating the table, which was empty. Then we run the first merge statement, and finally the last one, right? And let's say that you would like to see how data changed between those 2 versions. And that's super easy, right? With Delta Lake format. We can refer to the previous version of a specific table using this version as of and a number. So I take a look at the customer's target table version 1 and I compare it with the current version. And what is this version 1? It is this row, right? Version 1. That's the one before the current version. If we don't specify any version, then by default it uses the current one. So I want to compare this version with this version to effectively see what changes were introduced by this merge operation. And I wrote a very simple select statement that joins those two rows, 2 tables. And we can see that, for example, row number 5, Eva, it didn't exist in the previous version. It has nulls, right? It simply means that this row was inserted in the last merge operation. But for example, for Eva, row number 4, we can see that city was changed from London to Berlin. And likewise for Bob, we changed city from Manchester to New York. And that's how easy it is to see the changes in your data, because Delta Lake tracks it, at least for some time. Now, this is fine, it works, but the thing is that we update all rows in the target table whenever there is a match in a source table, right? And maybe we would like to filter our source table because, well, that's the whole goal of our pattern, right? We don't want to read everything from the source. We want to filter it. And yes, that's possible. We can add filters like this. I added this where last updated is bigger than the current date. This condition here is just a dummy one. In real life, you would implement it in a different way, and I will show it later. Here it is used just to show you that we can filter this data, right? We don't have to take the whole source. And because this condition doesn't return any data, because we don't have any new rows in source, then the result is that nothing was updated, nothing was inserted in the target table, right? Because no new source data was detected. And there's one thing that we would like to add here to our merge statement is maybe even if there is a match between source and target table, and even if we filter only those new rows, we would like to perform the update operation only under some additional conditions, like here. I added this end comparison, this end condition, that we want to update our target rows only if the name between source and target differs, right? Because maybe in this case, that's the logic we would like to have. And you can add multiple conditions if you want. So basically, that's how merge works. It allows you to easily grab data from one table, detect if they are new, updated or deleted, and then do with them whatever you want. There is one thing that I didn't show here on purpose. I didn't show deleting data from the target table if they are not found in the source. Why? Because in data analytics solutions, deleting data is risky. Maybe you would like to just mark them logically as deleted without physical removal, but that's a different story. Alright, so let's move on. A very important thing to remember is that even if we know, me and you, which source data is changed, and we filter it here based on this last updated or whatever column you use, it doesn't mean that the query engine will be able to effectively process those rows. And in some cases, you might be required to help it to read those changed data only. And depending on a query engine you use, it might be done in a different way. For example, in SQL Server, you would use indexes. In Azure Databricks, you would use liquid clustering. And I would like to show you what happens if you don't do this, how performance might differ. So let's switch to a different notebook that again uses a merge statement, but on a way bigger data sets, just to show you the impact of thinking about performance and when you don't do this. So what I did, again, I use bronze and silver schemas and this additional config one. That's the one in which I store my metadata table. And let's create my source table. It is bronze orders table. This time it contains real data taken from sample dataset provided by Databricks from orders. And what I do here is just I'm replicating this source data 7 times, just to have more rows that are available in the original table. Because with more rows, it will be easier to notice this performance impact. Alright, so the table has been created. Let's see how many rows we have in our source table, bronze orders table. And we should have about 50 million rows, right? Depends on your case if it is much or not much, but it is enough to show you the performance implications. And please note that our bronze orders table was created without any performance optimizations in mind. Let me create yet another source table called bronze orders clustered, but this time it will be created with liquid clustering. And liquid clustering is one of the techniques available in Azure Databricks to improve performance. And because I know that I will be filtering this table based on our updated timestamp, that's why I cluster it by this column. Now, this video is not about performance optimizations in general. I just want to show you what happens if you don't think about it, right? So I will not explain here what liquid clustering is, just go with it. But please note that I use the same data that was already loaded to our bronze orders table. So both tables, the regular one and the clustered one, contain the same rows, but they are just organized in a different way. The clustered version of the table is liquid clustered by our update timestamp. Alright, and let's start looking at the performance with a very simple select query. When we look for rows that were updated on a specific day, and let's start with our bronze order table. That's a table that doesn't have those performance optimizations applied. And it works, it's pretty fast. The dataset isn't that much, to be honest, but let's take a look at the performance data. And now, there is a lot of stuff displayed here. Again, I will not deep dive into it. I want to highlight this metric, bytes read. It means how much data this query had to read, right? And it read 446 megabytes. And let me copy this to Paint, because we'll compare it with the optimized version. And this filter here, it shows that 0% of data was pruned during scan. But what does it mean? Well, if we go into query profile, and that's the execution plan of our query, we can see here at the bottom that our source table bronze order was scanned. It was read, right? And this table, it has 444 megabytes in total, and the data is spread over 3 files. And my query, that was quite selective because we were asking for rows with a specific update timestamp. This query resulted in reading the entire table. The full table had to be read. And also, no files out of those 3 were skipped. Databricks had to read all 3 files just to retrieve those rows matching my select criteria. Not that great, right? What if we run the same query, but on the clustered table, the optimized version? And now, because those tables are pretty small, don't pay attention to the execution time, right? Because they are similar. Let's take a look at this bytes read metric. This time it's way smaller, and let me paste it here. This query had to read 4 times less data than the previous one, and also it was able to skip 87% of data. And we can verify this by looking at the query profile at our scan table. And please note that this version of the table is slightly bigger than the previous one. And it is bigger because we asked Databricks to organize it, to cluster it in a different way. And it is also spread over 8 files instead of 3. But what we see, that this time the query had to read only 80 megabytes out of 600 megabytes that consists of the table. Also, 7 files were skipped, which means that this query running on the optimized version of the table had to read way less data than the previous one, which in turn means that it should be faster and cheaper. Alright, but that was just a very simple select statement. How does it look if we apply it to the merge statement? So let me create the target table, this silver orders table. That's the table to which we load our data from our bronze order table. And what I do at the same time is that I'm populating this table with data from bronze orders, right? So actually both tables will contain the same set of data because I want to test the update performance. Then let me create our metadata table. That's the table inside which we store information about last successful start of processing. Or actually, we stored the date of last start of last successful processing. Exactly what I described in the previous video. And we populated this table with some dummy data that our silver orders table, our target table, was successfully processed on this date, right? And please note that here for simplicity, I'm using dates. In real life, you would use timestamps, which have way more precision, milliseconds or microseconds even, right? But just to make it simpler, let's stick to dates. And then let's write our merge statement. So what we do here, we merge into our silver orders table. We read data, in the first case, from our non-optimized table. We filter the data from the source table based on the metadata table, right? So here the value is not hard-coded, and we match the data based on some primary key. And then we apply some business logic. We update the data or insert data, right? So this is a little bit more complex example when we don't just do a very simple one-to-one insert or update. We apply some additional logic here. And I want to show you the comparison of performance of those two solutions, especially taking in mind that we filter the data based on this updated timestamp, because that's the rows that we know are new, are changed. And again, let's take a look at the performance metrics, and let me copy this. So this version of the table, of the query, it had to read 553 megabytes of data. Some data was pruned, alright, but what was pruned? And by the way, take a look that this time, this query profile, this execution plan is way more complex because we use merge statement here, not the simple select one. And here, that's the place where we read data from our source table. And we see that now this table again is read fully. No files were pruned. So we had to read, or the Databricks had to read full table, even though we specified this date filter, but it was not able to find the data effectively, and it had to read the whole source table. Here, this scan, that's the place where Query Engine reads our target table. And here the pruning took place because Databricks determined that it can skip 6 rows out of 6 files out of 8. And it made the trick, it updated the data, and it went fine, right? Now, let's compare this situation with a query executed on a clustered table. But to be fair, let me recreate our target table, right? So we don't have any cached data, we don't have any additional things existing data that might skew the processing. So let's wait a bit. All right, the silver orders table have been recreated. And let's go back to our merge statement. This time, let's use our clustered table as the source, and let's run it. And let's verify how the performance differs, especially when it comes to amount of data the query engine had to read. So let me copy this. And yeah, this value is smaller. It's way smaller than it was in the previous version, right? And why? Because a lot of data has been skipped. It was pruned. And let's see where the pruning took place. So again, if we take a look at our source table, we can see that yes, a lot of data has been ignored during reading, because Query Engine knew that there is no point in looking at this data, because for sure this data that we are looking for is not stored there. It also was able to skip those 7 files from the source table. When it comes to the target table, it again skipped some files. But at the end, number of rows data is smaller compared to the version in which we didn't optimize our source table, right? In both cases, the same logic was applied. In both cases, we filtered the data based on the same date. But in the second case, we helped Databricks to effectively read this data. So that's important, right, to remember. And let's get back to our example, just to combine all of this into a single cell. So how the full pattern could look like. So basically it contains 3 steps. So in the first step, we remember the current date when the processing starts. And again, here for simplicity, it is a date. In real life, you would use timestamps. Then we perform our merge operation with filtering the data based on our metadata table. And finally, at the end, if that succeeds, we update our config metadata table with the date that we remembered at the start of the processing. So let me run this. And we obviously run the query on the optimized version of the table, so it would be faster. And basically that's how the pattern looks like. And if we take a look at the configuration table or metadata table, we see that indeed it was updated to current day. Now, a few notes that you have to be aware of. This pattern, at least written in the way I'm showing you right now, it works as long as there's only a single process running at the same time. If you had multiple notebooks doing the same stuff, it could get nasty, right? So make sure that if you follow this pattern, there's only a single process, single notebook doing the stuff. All right, so let's summarize this. So by combining those 2 videos, you can effectively process data incrementally. So first of all, you know how you can detect new or change data in the source, right? Using this additional metadata table. And then you should know how you can use this detected data to effectively insert or update data in your target table. And for that purpose, you can use merge statement. And the very important thing is that performance has to be taken into consideration, because if you don't do this, then you might not benefit at all from the filtering that you applied, that you wrote in your query. Well, it will reduce the amount of rows that are processed later on, but the query engine would have to read the whole table. And the point of doing incremental processing is to make it as short, as fast as possible. So take this into consideration. And that's it. Thanks for watching and see you next time. Take care.